Okay, welcome back. It is day 196, I believe, of coding every day. I'm actually not going to be coding in this video. Um, I thought it would be cool to go over my research, knowing that I've been coding. I was thinking about it. I still want to like obviously do like fully codes and stuff like that and projects if they come along. But at least for like this summer, there's a lot of days where like this is the first time ever I've done this much coding work in a day. Like I'm doing 9 to like 4 p.m., sometimes 9 to 5, sometimes I work after that as well. So it's a lot of coding to be honest. So the point of me starting this was mainly just to make sure that until I get a full-time position at like a tech company, that I am staying familiar, even, you know, if I mean, the main thing was that fall semester that I started last year. I didn't have many coding classes, so I wasn't coding much. And then throughout this semester, I was coding a lot, and so a lot of the time I was just doing my class on these videos. And now I'm coding every day from the longest sessions of coding I've done. So um, I hope that's a reasonable reason as to why some of these videos this summer might just be me doing this. Maybe like every Friday, I will just go over my slides for that Friday. So yeah, so I want to show you my presentation and just so you can kind of see what I've been working on. So this was a literature review slide that I presented today. The one on the left is something that I don't think I'm actually going to put into our project. It's the idea of like a digital twin, like something instead of just having this like physical layer that sends information from all the sensors into this, it goes through like an MQTT server and does all its processing on there. Um, and then like there'll be like a model sitting there for image detection and whatever its result goes to the MQTT server and anything subscribed to that event, like a video capture event, would go there. The idea of the digital thing is like you could simulate ahead of time changes and then you could see how it affected the environment and then apply those changes to the actual physical room. It's definitely an interesting concept. I just don't think I need it. And it's, we only have 9 weeks for this research, so I don't see myself putting this in there. And then this paper was just going over a review of like 50 other papers. It basically just pretty much looked at the best models and technology that people used with the sensors um, in the smart homes. Yeah, so just using CNNs for image detection and RNNs for time series data. Game engine stuff. So I started this week using Unreal Engine, um, which I mean the detail on Unreal Engine is insane, especially for like that human creation, like this image here. Um, there was like a tree graph that went over like every bone in the body of like an avatar, and you could like animate all of it. It was insane, but it was really like heavy, and it just took a long time to do anything. And I barely started developing with it. I had a one room scene and a character rendered, and my laptop couldn't handle it. So I switched over to Unreal. I switched over to Unity, and you can see that down here is the Unity setup. Actually, if I go one more, this is looking at the Unity setup. So I just have like this room. I have a main room, a bedroom, and a bathroom. Um, all with there's motion sensors on the doors, which are just like box colliders. And so when you walk through or walk into one of those box colliders, it sends a message to my MQTT server, which I don't know if I actually. Oh yeah, this bottom one is the MQTT broker. And so what happens is you walk through there and it publishes to the broker saying like, hey, there's motion in the bathroom, motion like detected in the entrance of the bathroom, and then it looks at a vector to see which way, if it was an entrance or an exit from the bathroom. And then the light system is subscribed to anything to do with the topic of motion, and it will trigger the lights correlating to the room, which is pretty cool. And then just talking, this was more about the MQTT situation, which is literally just what I went over for that. Now, some things that I are kind of changing from what I did here. This is like a roadmap or whatever, which moved ahead a week. So data collection will probably be next week and not the week after. Maybe even training some models this week. Um, but definitely should start training some models the week after. But there was something really cool that my mentor was talking about, which was using um, using Wi-Fi, like the actual wave, like signal waves that go propagate through like a house and whatnot, to do motion detection. Because one of the big issues here is invasion of privacy. So like having a camera 24/7 surveying someone is just like, who really wants that? So although like yes, that'd probably be the best way to detect stuff like this, which would be ASD, motion, and behavior. It A lot of people might not want to subscribe to that. So this idea of having a router basically doing constant pings, so there's always signal going out and being received by, it has to be like some sort of receiver. Like I think the Intel 3500 is a device that is a receiver and transmitter, that can get a certain type of data. Again, I've only looked into this for like today, um, but it was like it looks at the certain matrices of data, and it can read, like if you walk through these waves that are being communicated, there's this Doppler effect where, like, I'm pretty sure if it's like you walk towards the receiver, it slows down or speeds up like the waves, or it also just disrupts like the waves in a way that you can actually see, um, like being transmitted, and you can tell how someone's moving through these waves, because everything else, if you have one thing propagating all these waves and then everything in the environment is still, right? It's just all furniture. The only change you're going to see is directly because of movement that I mean, mostly there are little things, maybe a breeze coming through the window or something like that. Um, but like for the most part, things aren't moving. So if someone's moving through it and it's messing things up, you can read what is messing up as movement. So that's something I'm going to be looking into for, honestly, over the weekend and then all next week. It would be amazing, because like invasion of privacy, this would literally kind of stomp that, because I don't think anyone really has an issue with their already propagating Wi-Fi waves. It's just numbers. Again, though, you can map that to movement, and I mean, if we just have an in-house system, I mean, like I know personally, if I had an in-house system that was tracking my movements and it wasn't going off into any cloud provider, I wouldn't care. Like I'm completely fine with an in-house system doing something like that better my life. It's just when you go out, when that data is going outside. But a camera is like totally like a live input that someone can maybe tap into. Something where it's like movement data is very hard to tap into and understand what's happening. So especially if they don't have the model that you're trained on. So yeah, that is all I have for today. Um, I hope you enjoyed my presentation of research, and let me know if this is something that I should do every Friday. Just go over my research for the week, or if you want me to just coding, if that's all you care about. So, yeah, I will see you tomorrow for day 197. Take care. Bye.